Okay, everyone. Today we're going to cover 7.2, the first half of it. We're going to talk about angles. Now, I'm sure you guys have already learned about angles before, but we're going to go through some old stuff and we're going to learn perhaps a few new things. Okay, first off, okay, how do we define angles? Okay, when two lines intersect, they form four angles at the point of intersection. I have an example right here on GeoGebra. Here I have two lines right here, one line here and one line there. Okay, they form four angles at the point of intersection. The intersection here will be I, and here, for example, we have one angle, and we have three other angles. Okay, one right here, okay, one right here, and one right here. So there we have four angles. Okay, what you call the corner, what you would probably call the corner, it can also be referred to as the vertex. Okay, so this will be the vertex right here, if we're looking at this angle right here. Okay? So looking at this angle, okay, we can this 90-degree angle, we can refer to it as ACB, angle ACB, or angle BCA. Now if you see a small letter by the angle, you can also refer to it by that small letter. So this can also be referred to as angle X, as you see this X right here. Okay? And we use degrees to measure angles. A complete rotation is 360 degrees. Okay, so the sum of all four angles here, this one, the 55.89 degrees, plus this angle, plus this angle, plus this angle, should add up to 360. Okay, so let's go through the types of angles. Now, you guys are probably often with the right angle. That's when the angle is equal to 90 degrees. Here, right here, we have a right angle. Okay, we can also have an acute angle. That's when the angle is less than 90 degrees. Okay, if you have a hard time remembering that, just remember that it's a smaller angle, and usually smaller things look cuter. Okay, so angle X right here is an acute angle. An obtuse angle is greater than 90 degrees but less than 180 degrees. So, for example, this right here, angle X is now 136.96 degrees. It is now an obtuse angle. Okay, and a reflex angle is between 180 and 360 degrees. So if you move it even further, okay, we see that this angle right here, BCA, is now 236.52 degrees. It's a reflex angle. Okay, but remember, even though we have a reflex angle, ACB, if we look at it the other way, if we look at it over here, from here to here, okay, it's not a reflex angle. It's an obtuse angle. Okay, and if we move it even further, we can see that it's now an acute angle. Okay, ACB can either be an acute angle or a reflex angle. Okay, perpendicularity. When two lines intersect and form right angles, they are said to be perpendicular to one another. So here we have line segments AB and CD. Okay, so AB is perpendicular to CD. Okay, when you see the square right there at the vertex, that means it's a right angle. Okay, we can also say that C is a foot of the perpendicular to AB. Okay, so C is the foot of the perpendicular. Okay, types of angles. Okay, we're going to look at three types today. Okay, when two angles have a sum of 90 degrees, they're referred to as complementary angles. Okay, so for example, okay, here we have almost 90 degrees. Okay, if we drew another line segment, okay, these two angles right here, this one, okay, if we look at this angle right here and this angle right there, they add up to basically 90 degrees. Okay, so they will be referred to as complementary angles. Okay, when two angles have a sum of 180 degrees, they're referred to as supplementary angles. So let's say I form, let's say I form a straight line instead. Okay, close enough. Okay, and then I draw a line segment. Okay, angle HCB and angle HCA should add up to 180 degrees. Okay, that means they're supplementary angles. Okay, last one, we have adjacent angles. Okay, adjacent angles share a vertex and do not overlap. So right here, angle HCB and angle HCA are adjacent angles. Okay. So because they share the same vertex, C and they don't overlap. HCB does not overlap with HCA. Okay. If it was ACH and HCB, then they would not be adjacent angles because ACH overlaps with HCB. Okay. All right, we have one simple practice question. I'll let everyone try to answer the question at the bottom of page 138, and that's it for your practice.